So in this video, we're going to be working with find the missing sides and angle in a right triangle. For this, we're still using the same thing that we saw on the previous lesson. So Katua here. Remember that this is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. On each triangle, on each exercise, I got to decide which function I'm going to use of those three. On this part of the lesson, we're not using the other three functions, the reciprocal ones, cosecant, secant, and tangent. We're just using sine, cosine, and tangent because those are the one on your calculator. And I'm going to explain here step by step how to put it on your calculator. Then we're going to see it in another video or in class, how to use particularly your calculator. So on this case, I'm going to start with the angle and identifying what information I have. So on this triangle, I have the hypotenuse, or they're asking me for the hypotenuse, and they're giving me the adjacent side. How do I know that that's adjacent? Because it's the one that is forming that angle with the hypotenuse. This is the opposite, that is on the opposite side, so I don't know this side. And actually, I don't need it because I just want to find x. So I'm going to write this as cosine of 64 equals to 7 over x, adjacent over hypotenuse, adjacent over hypotenuse. And I'm going to solve this. I'm going to multiply times x on both sides. So I got x, cosine of 64 equals to 7. And then cosine of 64 is just a number that we're going to find on my calculator. And I'm going to write it like this, cosine of 64. So by going to your calculator, make sure that your calculator is in degrees first, and then we're going to write 7 divided by cosine of 64. And that should give you 16. Why 16? Because it should give you 15.96. So if we round it to the nearest tenth, it's just going to be 16. Okay, let's see number 2. Again, number 2, this is the angle that I have, that 20.5 down here. So I got from the angle, they're asking me for the opposite, they're giving me the hypotenuse. So that means that I'm using sine of, again, 20.5. Again, sine, cosine, and tangent, the same with the reciprocal one. They need an angle. In this case, we know the angle. So again, this equal to opposite over hypotenuse. So that means that this equals 2x over 14. To solve here for x, I'm just going to multiply times 14 on both sides. And I'm just going to go to my calculator to find 14 cosine of, or sine of 20.5. And this is 4.9. 3. So I got the angle 53 down here. So I got the opposite. I got the adjacent side. Anytime that you see one that you don't have the hypotenuse, automatically we're going to use tangent of 53 equals to 5 over x. So opposite over adjacent. Now, anytime that you have the variable on the denominator, at the end, you're going to have something similar to this, right? So I got x tangent of 53 equals to 5, and then I can divide by tangent of 53, tangent of 53. So at the end, you're always dividing the number by tangent, because if I multiply and so on. So again, I'm going to go to my calculator. 5 divided by tangent of 53, that equals 2, x equals to 3.8. Okay, so number 4, again, from here, I got the hypotenuse. I got the opposite. So I'm using sine. So I got sine of 28 equals to 11 over x. Again, I'm going to multiply times x and divide by sine. So I get 11 divided by sine of 28. And by going to the calculator, you should have 23.4. Again, this one are pretty straightforward because if you look at your calculator, you should have the keys for sine, cosine, and tangent just right there. Very important, on your calculator, make sure that you press the key mode, and somewhere around the third or fourth lines, you should have something that says radian and degree. For now, make sure that the one that is shaded is degree. If radian is shaded, just go down with your arrow and go to degree and press enter, and that's shaded, and then you should have the same answers as me. Let's go to this one. Right now, I want to find the angle given that cosine of y equals to 0.7193. As you know, anytime that we're solving an equation, we're using the inverse function. So it's the same here. I'm going to use an inverse function here. So if I apply the inverse on both sides of the equation, technically this cancel out. We don't have to do those steps. I'm going to show you number 6. Y equals to the inverse of cosine of 0.7193. Now, on your calculator, you're going to have to do the following step. So you're going to press second first, and then on top of the key of cosine, you should see something like this, cosine inverse. So by pressing second first, you're using that function for that key. So if I go to my calculator, second cosine of 0.7193, that should give you 44 degrees. Again, number 6, so z equals to the inverse of 0.9135. Again, we're using the inverse only when we're trying to find the angle. Those exercises up here that we already know the angle, like this one that we already know that is 28, we just use the regular function right there. So the second inverse here, again, here I'm going to press second first. So second. And then I'm going to use the key sine. That on top of sine should say sine inverse. So second sine, 0.9135. Enter. That should give you 66 degrees. Okay, so number 7, again, on this case I got tangent, so I'm using the inverse of tangent. So tangent -1 equals to 4.3315. Okay. So by going to your calculator, in this case again, second tangent 4.3315, it's going to give you 77. And then the last one, sine. I'm using the inverse. Second sine 0.2588, which give you 15. Keep in mind the following. On sine and cosine, this value over here has to be always less than 1. A little bit later, we're going to see that it could be negative, but for this type of exercise, it's going to be less than 1, between 0 and 1. Tangent can be any number. See this. Now we're finding the angle. I want to name that, instead of this, I'm going to name it theta. So again, I'm going to identify one information from the angle I have. So in this case, I have hypotenuse, and I get adjacent. So that means that, going back to SOHCAHTOA, I'm using cosine. So I got cosine of theta equals to 20 over 45. On this case, because my answer is not the fraction, if you want to simplify, you can, but you don't have to. So theta equals to, again, I'm finding the angle, so I'm using the inverse. Right? So 20 over 45. Again, if you want to simplify that fraction, it should give you exactly the same as long as you simplify it correctly. So going back to my calculator, again, second cosine, I can write that fraction directly, 20 over 45. That should give you 63.6 degrees. Or in this case, now I see that it's to the nearest degree, so this should give you 64 degrees. Let's see, number 10. So again, theta. From theta, still have the adjacent. I got the hypotenuse, so I'm still using cosine of theta equals to 37 over 39. Again, remember that your hypotenuse is always the longest side. So 37 over 39. So that means that theta equals to the inverse of 37 over 39. By the way, you can go directly to this step. You don't have to write that one. If you already know that you're finding theta, and you have cosine inverse of 37 over 39. Again, second function, cosine 37 over 39, and that equals to 18 degrees going to the nearest degree. Let's go to 11. Again, here, let's name this theta. I got opposite, adjacent. I don't have the hypotenuse involved on this exercise, so that means right here, again, I can go directly to this. I'm using tangent. Again, why? Because I have only the opposite and the adjacent. I don't have the hypotenuse. So tangent of 4/13, opposite over adjacent. So going to my calculator, second function, tangent, 4 divided by 13, close parenthesis. So this equals to 17 degrees. So on this one, again, I got that's theta. I got the hypotenuse, I got the adjacent. I'm still using cosine. So cosine of theta equals to 6/25. So the inverse, 6/25. So that equals to 76 degrees going to the nearest degree. Keep in mind that here, you can also use sine. For instance, here that all those 4 exercises had cosine or tangent, not sine, but we can use tangent depending on what information you're given. And that's it for this lesson. May the force be with you.